Very good morning. We had been discussing about introduction of artificial intelligence. Then we had started discussing about knowledge representation. How important it is to represent knowledge and how important it is to understand how and where we are going to use knowledge when we are talking about all the artificial intelligence applications. We have understood very well that there are so many diverse applications possible with AI and what is need of representing knowledge efficiently and in unambiguous ways. So we had started discussing about knowledge representation issues from last lecture. Today we are going to continue with the same. What we had discussed in last lecture, that what is importance of representing knowledge, why we should be having knowledge, then what all we are going to write in knowledge. We have understood the difference between fact. We have understood how we are going to map this fact to generalized representations. We have seen how we are going to represent these facts at two different levels. We have also discussed there are certain terminologies we need to understand from for knowledge representations. Then we have discussed about the desirable properties any good knowledge representation technique should have. We had even seen the practical properties our knowledge representation technique should hold up to be a good knowledge representation so that people can understand it properly from the representation and it is easier for manipulation as well. Because we are not just going to represent knowledge, but what we are going to do is after representing knowledge we want to manipulate it. What is meaning of manipulation? We want to infer new knowledge. Also we want to ask certain queries and we want to retrieve the solutions of those problems or questions which we are going to ask to our knowledge representation system, right? So we have seen the properties, the ideal properties, the practical properties which good knowledge representation schemes should have. Then we had discussed that for a knowledge representation what different possible techniques are there, means in which all ways a knowledge can be represented. For discussing that, again we had discussed that what are the different approaches knowledge representation can be done. And we had seen that there are four basic approaches how knowledge can be represented. The very first and basic knowledge representation approach we had discussed in the last lecture, which was the last topic we had discussed, that was the relational knowledge representation. We had seen that just like the database we used traditionally, we can represent our knowledge in the form of tables. So what we are going to do over here is from our problem domain, we will identify all the objects and all the entities. And what we are going to do here, after identifying the objects and entities, we need to identify all the qualities, all the properties, attributes which that object or entity is going to hold. Now we are going to create a table which is called a relational knowledge representation, such that all the entities or instances which we have identified, they are going to be written as different rows of the table. And all the attributes which we are going to use for describing those objects or entities, they are going to be written as the columns of the table. So as we have discussed in the last lecture, we can have a table storing the information about all the musicians. So the name of the musicians will be in the separate rows, unique rows for each unique musician. And then the qualities of musician, like the musician is dead or alive, alive then which age, which instrument that musician is playing, which genre that musician belongs to. All these properties can be written in different columns. So this is a simple possible represent knowledge representation. What is the advantage? The simplicity, because it is very easy to represent. But then what is the disadvantage? It is very basic. Hence, if you want to infer new knowledge out of it, it is very difficult. It is very difficult to manipulate it and infer new knowledge. And it is also going to provide you very less answers of your questions. Like only the straightforward questions can be asked to that approach, not many indirect questions can be answered through this basic approach. So this is what we had discussed in last lecture about the relational knowledge representation. So after this, we are going to discuss about inheritable knowledge representation, then inferential knowledge representation, and the last is procedural declarative knowledge representation. So we are going to discuss this today. So let me share the presentation and we'll be discussing them in detail ahead. Okay, fine. So today we are going to discuss inheritable knowledge. So in last lecture itself, we had started discussing about inheritable knowledge. What we had discussed, many a times our problem domain is very generic. Generic in a way that all the objects or entities which we have identified, they can be represented in form of hierarchy. Generalized hierarchy. What kind of hierarchy? Let us take the example. In example over here, we have taken the domain of baseball players. In the domain of baseball players, we can see that the objects we can, I'm sorry, objects which we can identify from the problem domain have certain relation with each other, and they can be represented in a hierarchy, generalized hierarchy, such that we will be having some super class, then the subclass of that super class, then again its subclass, and so on. So this is called inheritable hierarchy, inheritance hierarchy. That all the entities or objects we are talking about over here, we have identified out of our domain. They are actually related with each other in some hierarchy at one level or another. For example, if we'll read this, in last lecture we have read this chart top to bottom in a showing the relationship between the superclass, subclass, means parent class, child class, and so on. Today we are going to read it bottom to top to explain you which all attributes it's holding. Before we discuss the diagram once again, let me once again tell you that all the boxes, rectangle or square boxes which we have used over here, they are indicating the entities, either the values of the attributes. So if I have drawn a square bracket, means a box over here, either rectangle or square, then that box is indicating you the entity or object. Either it is entity or object, or it is representing value of attribute, not attribute, but value of attribute. So where attribute has been written, attributes are written on the directed edges. Means wherever you are having the directed arrows, those arrows are labeled by the name of attributes. So attributes are written on the arrow. Are you getting this? Okay. I'm sorry. So if we'll be reading this diagram bottom to top, then let us talk about three finger brown and P viris. So these two are the pseudonyms or alias name of baseball players. So if we start from three finger brown, so three finger brown is a person, a player who belongs to the team Chicago Club. So team is the attribute over here, and the value of team attribute is Chicago Club, Chicago Cubs. Are you getting what I'm trying to say? The object we are talking about over here is three finger brown. So three finger brown is object. That object is having one attribute, team. What is value of team attribute? Chicago Cubs. Okay. Now again talk about the second object we are talking about, P viris. Now this P viris once again is a pseudonym of a baseball player, and this player is belonging to the team Brooklyn Dodger. Now again this object is having the same attribute, team attribute over here, and this value of the team attribute is Brooklyn Dodger. Now see, once again, these boxes are representing either object, means three finger brown or PV or the attribute values, means Chicago Cubs or Brooklyn Dodgers. And attributes, that is team, it is written on the arrows, right? Okay, now let us read this in the hierarchy, bottom to top. So if I'm talking about three finger brown, means this specific player, then this player is instance of pictures, instance of the object or entity picture. Okay, so here a word that we must consider is instance. What is instance? So if you observe on the PPT on right bottom side, I have explained what is instance in the highlighted colors, because this is very important property. What is instance? Instance actually indicates class membership. Now what is meaning of class membership? It is something like being part of the class. If I take example, then let us say we have a set written in curly bracket A, comma B, comma C. Imagine you have a set where there are three values A, B, C. So we will write it like in curly brackets A, comma B, comma C. If I'll ask you, is B member of this set? What will be your answer? Yes. So we can say D is member of the set A, B, C. So this is called class membership. Similarly, the class picture, the set picture has so many players, and three finger brown is one of the member of the class picture. Are you getting what I'm trying to say? So what instance means? Being member of a set. So picture is a set which contains different members, different objects, and one of the object is three finger brown. Are you getting what I'm trying to say? Just like A, B, C in the curly bracket, if you write name of all the players, then one of the player, three finger brown, is member of that particular set, and the name of that set is picture. Okay. So what they mean by instance? Instance means class membership, being member of a particular class. Okay. Similarly, if we talk about PVRs, then PVRs again is the instance of the class fielder. It is instance of the class fielder. Means, what is meaning of instance? Just we discussed, being member of. So imagine a set of all the players who are fielders, who are not pitcher but who are only fielders. So let us say we have written all the names in curly brackets separated by commas. Then we can say that PV race is one of the member of this set, and we'll give the name to this set as fielders. Are you getting this? So here we can say that these two objects, three finger brown and PV race, they are member of their appropriate sets, pitcher and fielder. So instance, once again, make it very, very clear that instance indicates class membership. Okay. Fine. Now, if we talk about the broader classes, that is pitcher class and fielder class, okay, I may use interchangeably towards class and set for the same object because it indicates both the things. What I mean by class is the object-oriented concept, that you have a parent class, then child class, and so on. So I can consider pitcher as a class. Okay. And when I say it is a set, what I mean? It can have different members inside. Okay. So don't confuse in it. So coming back to the pitcher class. Pitcher class may have different attributes, and one of the specific attribute it has is batting average. So for pitchers, the batting average is going to be, what is the value? Again, value is written in the box. So what is the value? Batting average is the attribute, and the value of that attribute is 0.106. So for all the pitchers, the batting average attribute has the value 0.106. Okay, so that is a specific value assigned to this particular class. If we come back to the second class we are talking about, this fielder, then batting average for all the fielders. Again, batting average is written on the arrow, so it indicates the attribute. So what is value of this attribute, which is once again written in a box? 0.262. So that is the batting average of all the fielders. So see, over here, we have taken the attribute batting average, which is asserting the specific values for these classes, and you are not going to inherit batting average from the parent class, which is baseball player. Are you getting this? I'll once again discuss as we'll be discussing the parent class. So pitcher and fielder are two subclasses, and their parent class is baseball player. Okay, so baseball player is a class which is having two child classes, pitcher and fielder. Now talking about baseball class, then you can read it like pitcher is a baseball player, and please pardon over here between fielder and baseball player also, here on the arrow Isa should be written. We will pronounce it like Isa. Okay, so Isa should be written here also. By mistake it is missing. I'll write it before sharing the PPT in the class. So Isa should be available over here also, because pitcher is a baseball player and fielder is also a baseball player. Okay. Now what I mean by is a relationship over here. See, whether we say instance or we say is a, both are very, very, very important attributes, and we must understand their meaning properly. So what is Isa? Isa indicates, check over here the bottom portion, bottom right portion where I have written the meaning of Isa. What is Isa? Isa indicates class inclusion. What is meaning of inclusion? Including something. What is meaning of inclusion? Including something. Okay, so it is like a set and a subset. So a subset is included inside a set. Are you getting what I'm trying to say? So imagine it like pitcher is a small class and it is part of the broader class baseball player. Are you getting what I'm trying to say? For example, you have one set which contains value A comma B, and there is one another set which contains the value a comma b comma c comma d comma e. So can I say the first set is subset of the second set? Why? Because all values which you have in the first set, they are actually present in the second set also. So there is a subset relationship between the first set and the second set. Are you getting what I'm trying to say? Pade she khabar? So this is class inclusion. Inclusion is something like subset relationship. So here we can say pitcher is subset of baseball player. Fielder is subset of baseball player. Are you getting this? So we can say, is ISA relationship clear? What is difference between instance and ISA? Instance means being member of the set and ISA means being a subset of a set. Okay. So Three Finger Brown is a player who belongs to the set pitcher, but pitcher is a set which is subset of the set baseball player. Are you getting what I'm trying to say? Okay. So pitcher is a baseball player and fielder is a baseball player. So instant and ISA both are both we have used over here are special kind of attributes. Coming back to the baseball instance over here. So what baseball object says? Baseball object itself has multiple properties. Which all attribute it has? So the first attribute is height attribute. What is value of height attribute? 6.1. The second attribute is batting average. What is the value? 0.252. Now once again let us discuss. Baseball player is the class over here and which is having two subclasses. Child classes pitcher and fielder. So all the properties baseball player has are going to be inherited by child classes. So height, batting average, these three properties of baseball player should be inherited by the two child classes, pitcher and fielder. But as we discussed in the last lecture, for a child class, it is not compulsory always to inherit values. It may inherit certain values and it may have its own values also. So see, for pitcher and fielder, you don't have any height attribute available. Pade che khabar? Height attribute is not available with pitcher and fielder, both entities. So if you will ask what is height of fielder, then we are going to inherit from the parent class. But if I'll ask you what is batting average of a fielder, then I won't reply 0.252. Why? Because fielder itself has its own exclusive value. So it is overwriting the inherited value. Are you getting what I'm trying to say? If it has its own value, it will override the inherited value. If it don't have that attribute, it is going to use the attribute value of the parent class. See, it's so simple. Okay. So what is value of bats attribute here for baseball player? Bats. See, I have not written box with bats. Why? Because it is recursively calling somewhere else. It says bats is equal to handed. What is handed? It will come ahead, handed attribute and its value should be assigned over here. Whatever is the value of the attribute handed, it should be written over here. So as and when we will come to handed, we will come back over here also. Now let us focus on baseball player again. Now what is a baseball player? Baseball player is a class which is subclass of adult male. So adult male is a parent class and adult male is the parent class and baseball player is the child class. So whenever we have parent class child class relationship, it is subset relationship and hence we will be having ISA attribute. Are you getting what I'm trying to say? So baseball player is a adult male. Okay. Now talking about adult male, which all attribute it has? Height attribute. What is value? 5.10. Once again, see, if I'll ask you the question, what is height of adult male? What should be your answer? 5'10". But if I'll ask you what is height of baseball player, then the height should be 6'1", not 5'10". Why? Because baseball player is the child class of adult male, so it is going to inherit the height attribute and value 5.10. But baseball player has its own height attribute value also, so it will override the inherited value and hence it won't use the height value of parent class. Are you getting this? Okay. Now adult male again is the subclass of the parent class person. So we can once again use which attribute? Instance or ISA? ISA. Whenever you have parent class child class relationship, you will use ISA. So adult male is a person. Now person has only single attribute and the value that attribute is handed. Means the person is working with which primitive hand, right hand or left hand. So handed attribute has the value right. As soon as we have over here the value of handed as right, that value is going to be assigned in the bats attribute over here with baseball player, because it says bats is equal to handed. So here also we will have the value right. Are you getting this? So this is how we are going to interpret this. Now from this diagram, how we understood inheritance, we can see over here that there are classes which are in hierarchy. We have a parent class, child class, the child class of the child class, and so on. But what is important, there are two attributes which we have discussed, which are very, very important. And throughout, we will be discussing knowledge representation. We are going to talk about these both attributes. The first is instance. Consider instance like object to the class. Okay, value to the member value to the set, and hence it is called class membership. And what is ISA? It is like subset relationship. It is like parent child subclass, class subclass relationship, and hence it is called class inclusion. Now, once this kind of relationship is available to us, how we can manipulate this? What is advantage of having inheritable knowledge? The advantage of having inheritable knowledge is, because of inheritance, whatever properties, whatever attributes you don't have for a specific entity, you can inherit from the parent. And all the queries which you are going to raise, mostly they are going to be answered from the object you have or from the inherited values. Okay, so to manipulate inheritable knowledge, we will use one algorithm which is called property inheritance algorithm. In many of the GTO papers, they have asked write and explain property inheritance algorithm, 7 marks. So you have to just write down these 8 steps, which are very, very, very simple. And that is nothing but property inheritance algorithm. Now, before discussing this algorithm, let me show you certain examples. Okay, suppose I'll ask you a question like, okay, focus on this diagram, everyone. If I'll ask you a question like, what is value of team attribute for 3-finger brown object? What will be your answer? Yes, can anyone reply unmuting? What is value attribute for team for 3-finger brown?
Chicago Cubs.
Exactly, very good. So see how you can answer this, because the object 3-finger brown is having the direct attribute available with it, which is team, and that attribute has the available value Chicago Cubs. So we can directly answer it. Okay. Now let us go to one level ahead. If I'll ask you that, what is batting average of 3-finger brown? See, what is problem over here now? 3-finger brown, that object. How you are going to trace this? First of all, I am asking question about which object? 3-finger brown. I am asking a question about which attribute? Batting average. So first question is, do you have batting average property attribute directly available with 3-finger brown? If yes, reply with the value directly available. But in this case, batting average directly is not available with 3-finger brown. Are you getting this? In that case, what we have to do? In that case, we'll see 3-finger brown is nothing but part of pictures, instance of pictures, one of the pictures. So what we'll do? Travel the instance attribute and go to the next object entity it reaches to. Once again, let me repeat. If you don't have the desired attribute directly available with your object, what you have to do? You have to travel in hierarchy with instance attribute first of all. Do you have any instance attribute available? Yes. So travel to that instance attribute. Where you will reach, go to that entity. What is entity we are reaching to? Picture. Now once again ask the same question. Do you have batting average attribute directly available with picture? Yes, it is available. What is value? 0.106. So return that value. Return that value as answer of what is batting average of 3-finger brown. So have you retrieved this value? Batting average is directly not available. So what do you have to ask? Do you have any instance relationship available? Then travel it. So you will reach to picture. Now do you have a batting average of picture available? Yes. So return that. So your answer of batting average of 3 finger brown, the answer is going to be 0.106. Okay, fine. If I'll ask you that what is what is height attribute for PV Rees? What is height of PV Rees? So again we will ask how we will start. Is height attribute directly away? First of all, locate PV Rees object. So it is available over here in the hierarchy. Then check. Do you have height attribute directly available with this object? No. If it was available, we'll directly return the value and finish the algorithm. But it is not available. So what is the second step of our algorithm? Check. Do you have any instance relationship available? Means your object is instance member of any class. Yes. Travel that and go to that particular class. So from PV is where we will reach to filter class. Okay. Now once again check. Do you have height attribute directly available with the class filter? No. Means filters won't also have any height directly available. So we cannot return the height value. So what you have to do? Now check. Do you have any ISA attribute available? ISA relationship available over here? Yes. Fielder is a class which is subclass of baseball player class. So fielder is a baseball player. If you have any ISA relationship available, travel to that ISA attribute and reach to the resulting object. So from fielder where we will reach, once again here it should be ISA labeled, which is not labeled. I'll revise and share the PPTs. So fielder, from fielder travel ISA and reach to baseball player. Again repetitively ask the same question. What question? For baseball player, do you have any height attribute directly available? Yes, it is available. So what is value? 6.1. Return that value. So that is going to be height value for which object? PV Rees. Are you getting this? How we retrieved the value of height? Here we don't have directly. So we first of all traveled instance. Instance will always be traveled only once. After that, every time we are going to travel ISA only. So we will travel to instance and reach to fielder. Then we will travel to ISA and reach to baseball player. And here we will locate height attribute. So we will return the value 6.1. But suppose I have asked you a question like, what is handed attribute value for PV Rees? What is handed attribute value for PV Rees? Then how we are going to start over here? First of all, we will check that for PV Rees object, do you have handed attribute directly available? No. So you cannot directly return the value. What we will do? Travel instance relationship for once. Instance attribute is traveled only once in the algorithm, else everywhere you are going to travel ISA hierarchy. Okay, because any object is going to be member of a single class only, and then you will have class, subclass, superclass relationship. Okay, any value will be member of one set, and then you have set, subset, superset, that kind of relationship. So travel instance and reach to fielder. Now once again check, do you have handed attribute available here? No. So travel ISA relationship. Go to baseball player. I'm sorry. Do you have handed relationship available here? No. So recursively keep on traveling ISA relationship unless and until the desired attribute is directly available to that specific object. So with baseball player, we don't have any handed attribute available. So what we'll do, once again travel ISA attribute and reach to adult male. Again ask, do you have any handed attribute value available with adult male? No. So once again, what you have to do? Adult male is a person. Travel is a hierarchy and reach to person. Now check, do you have handed attribute available? Yes. What is value? Right. So return that value. Which value we have returned here? Value of handed attribute for which object? PV Rees. So question was, what is handed attribute value for PV Rees? And have you traveled PV Rees to fielder, fielder to baseball player to adult male to person, and at person you got the value of handed as right. Are you getting this? Suppose I'm talking about weight attribute of a person. What is weight of PV Rees? How you will start? PV Rees, locate it. Is with attribute available? No, so you cannot directly return. So instances traveled for fielder. Is with attribute available? No. So travel is a hierarchy. Go to baseball player. Check. Is weight attribute available? No. So once again, travel is a hierarchy and reach to the super class, parent class adult male. Check with the adult male. Do you have any weight attribute available? No. So once again, travel is a hierarchy. Go to person. Now, interestingly, check over here. Do you have any weight attribute available with person? No. So return false. What it is? It means the attribute which you are searching for is not available in hierarchy. So we cannot answer this question. So from this knowledge base, you cannot answer what is weight of PV is because your knowledge base, inheritable knowledge base is not having any information about weight. It is neither there available in the object nor in the class or superclass or parent class or the super parent class. Nowhere weight attribute is available. So it should return false. It don't know about this value. Are you getting this? Now, whatever I have discussed here in calculating values, the same we have written in form of algorithm. So when I'm describing algorithm, remember these questions. The first question was what is team attribute? So that is what we are discussing as the first value. Retrieve the value V for attribute A of the object O. For retrieving the value means for any object O for desired attribute A, when you are searching for value V, follow the following steps. Perform the following steps. Okay. Once again, for any object O, there will be attribute A, and for that attribute A, whenever you are searching for value V, which steps you should do? Following. What is the first step? Find and locate object O in the knowledge base. So if I am asking you question about what is team attributes value for three finger brown, what is your first step? Go and locate three finger brown over here. So I have located here. Okay. Okay. What is the second step? If there is a value for attribute A directly available, report the value. So after locating three finger brown, I will check whether team attributes value is directly available. Yes. So I'll return the attribute value Chicago Cubs. Are you getting this? So this is how it is working. If the value is directly available, then return that value. Okay. But suppose I am asking you a question like what is bats, second question, like what is batting average of PVRs? What is batting average of PVRs? So what you will do, first of all, locate PVRs. Then check whether directly batting average attribute is available here. No. So you cannot return the value as per step number 3. So if not, then you will have to go to step number 4. What step number 4 says? Else, if there is a value for attribute instance, if check, do you have any instance relationship available? If not, then fail. If not, then fail means you cannot get any value. But if yes, then what you have to do? Go to step number 5. Okay, then what you are going to do? Move to the node corresponding to that value and look for the attribute A. Means if yes instance is available, so what you have to go do? Move to that particular object. Okay, and check is the batting average attribute available over here? Yes. What is the direct value for batting average here? 0.262. So once again, see, move to the node corresponding to that value and look for the value of attribute A. If there is a value available, then report the value. So if I'll ask you what is batting average for PVRs, then we will go to this step. Directly it is not available, so we will travel instance, go to filter and report the value 0.262. So this is example how you are going to report the value at step number 5. But if the question is like what is handed attribute value for PVRs, then what will happen? You travel to filter. Traveled direct value is not available, so you check whether instance is available. Yes. Travel and go to filter. Once again check. Do you have direct value available for this particular object's attribute value handed? No. So what to do next? That is what step number 6 says. If you don't get value over here, then do until there is no value of ISA attribute or until the answer is found. Means either keep on traversing with ISA until the answer is found or there is no more ISA available. There is no more hierarchy available to travel ahead. What do you have to do? Step number 7. Get the value of ISA attribute and move to that node. Go to that node and check whether the value is available for that node. If not, then once again go to step number 6. Check for the ISA attribute available. Check step number 7. Go to it. Means what we did over here, that for fielder handed is not available. So go to ISA baseball player. Handed is not available. Go to ISA. Check handed. No, not available. Go to ISA. When we will stop, either the answer is found, or in case of weight attribute where we stopped, because person is the generic class and after person there is no ISA attribute available. So stop that. Are you getting this? So what we'll do, if the value is available, then report it. And if the value is not available, then report false, fail. Are you getting this algorithm, everyone? Yes or no? Everyone is clear with this algorithm? With the examples we have done? Can someone please unmute and answer? See, this is very important. It is asked many times in GTU question paper. So I am asking, are you getting this algorithm?
Yes, ma'am.
Okay. So see, you need not to cram this algorithm. Don't cram it. You can simply remember the examples we discussed, like what is the team of three finger brown. So that is going to make your step number 1, 2, and 3. Then what is the batting average for PV race? Then it is going to make your step number 1, 2, 3, 4, 5. Then if you ask what is handed attribute of PV race, then it is going to make your step number 1, 2, 3, 4, 5, 6, 7, 8. Simple. So in that sequence, and it is not compulsory that you have to write the exact words. Whatever way you have understood the algorithm, simply that way you can write it. Okay, fine. Now, the algorithm is very simple. It describes the basic mechanism of inheritance over here. It does not say what to do if there is more than one value of instance ISA is available. So the question which we discussed over here, the same questions have been discussed over here. What is team for attribute for PV race? What is batting average for this? What is bats for three finger brown? If you have to check what is bats for three finger brown, how you are going to check? Three finger brown, bats attribute is not available, so travel instance. Pitcher, bats attribute is not available, so travel ISA baseball player. Bats attribute is available. Handed, so go to handed and return right. Clear? So this is all about how the property inheritance algorithm is working. Okay. Now the next is inferential knowledge representation, but we'll be discussing this in next lecture, as we'll have to finish. 40 minutes have finished and we'll have to finish. Now, before we will be discussing more about the other topics, and you will be resuming to quiz. Please resume to quiz after 2-3 minutes, as I'll have to edit and eliminate few questions, because quiz may contain certain questions which I have not discussed. So I'll